All right, this is the video answer key for your study guide. Your test is over expressions and equations, part 2. So you want your study guide in front of you and something to grade with. Just a reminder, it is always helpful if you've done that as well as you can first, so that when we're going over this, you can learn from it and check your progress. So that is just a reminder. Hopefully you've done that. Hopefully it's in front of you right now, and let's start going over that. Well, there was really 4 learning targets on this particular study guide, and those main skills are these right here. We are solving one-step equations. We're writing equations for real-world situations. We're solving and graphing one-step inequalities, and we're writing equations for situations that we can graph or put on a table. So these are the big things from this unit. Now, what I would challenge you with is the assumption that your test is similar to your study guide, but you know it's not the same. So you always want to be thinking, how do I know this material? What else could they ask me or think about doing on a test that would be similar to what's on the study guide, but still unique enough? Because remember, the study guides are just a good measure of the test, but they are not the test. So we want to prepare as we're going along here. In this first section, you were to solve one-step equations. All right, all of these had a variable, and you were to solve them. Now, the reminder we would give you when you're solving for a variable is that you want to isolate the variable. All right, this reminder down here is what we want to do every single time. And the way that we isolate variables, this is just a reminder now, we use inverse operations to solve one-step equations. Inverse operations would be the ones that are opposites, okay? These are inverse operations. Multiplication and division are inverse operations. Now I'm going to show 4 examples here, but this is just a reminder. I mean, if you are not sure how to solve a one-step equation, pause the screen, study these, and see how they arrived at the value of the variable for x and n and k and y. Go ahead and pause it, because the assumption by now is that you know what we're talking about when we say inverse operations and that you know how to do this. So pause if needed, study that screen a little bit, maybe ask your teacher a question or two. But we're going to look at these now, because the goal here is to get the variable by itself, isolate the variable. And if we're adding it with 10, we really want to subtract 10 from both sides, because that will get rid of what's being done with the variable. But you do it to both sides to keep it balanced. So we end up with an x value that has to be 14. Remember that for equations, there is one value that will work. All right, that's where our understanding is at. In number 2, if this is the variable and I am subtracting a half, I want to add a half to both sides of that equal sign. The left side of it, and those will cancel out, and to the right side of it, which means I need to do some addition of fractions. 3/10 plus a half. Well, if I convert, I get 3/10 plus 5/10, and we know that that's 8/10, or we can simplify it down 4/5. So x has to have that value. If it does, then this problem would equal 3/10. So that's our answer. In number 3, remember that this is division. Okay, m over 20 is really m divided by 20. So I just rewrote it. And I want to get that m by itself, so I undo what's being done to it. I multiply both sides by 20. And if I multiply this side by 20, I rewrote it up here, 20 times 4/10, I end up with an answer of 8. M has to be 8. And number 4, 15 times x. Well, if x is being multiplied with 15, we want to undo that. So we divide both sides by 15. And we end up with a value of 6. So that is the first 4, solving one-step equations. You can always know if you're right or not just by plugging in your variable back in the problem to seeing if it makes it true. Because if you plug it in and it doesn't work, then something's wrong and you want to figure out your mistake at that point. But that's how you can check the first 4 to see if you did them right in the first place. In number 5, now we're going to take this a little further. If b plus 20 is 24, what's the value of 2b plus 1? And we want to prove it. Well, the first part here, if this is what they tell me, that's just like what was above. I want to get the variable by itself, so I subtract 20 from both sides, and that gives me a value of 4. B has to be 4 to make that true. We agree with that. But there's a second part here. If that is true, then what is the value of this? Well, we now take our value and we substitute it in there. 2b plus 1. Well, that would really be 2 times 4 plus 1. Well, where'd that 4 come from, you ask? Well, we already solved it over here. That's where the 4 came from. So now we're going to plug it in there and solve this problem. So that would be 2 times 4 plus 1. Well, we know that's 8 plus 1. So the value of 2b plus 1 is 9, all right? And I proved this by showing my work. Okay, that's one way to prove it. You could also use words or pictures or something else, but those approaches all need to be one that proves your work. All right, this we've already talked about. Let's look at the next learning target section here. Now you want to write equations that will help us solve these problems, okay? So in this first one, a board that measures almost 20 meters in length is cut into 2 pieces. One of those pieces measures about 7 meters. We want to write and solve an equation that finds the length of the other piece. So the assumption here is that one of these pieces will be shorter and another will be longer, but combined, they add up to that almost 20 meters right there. Now, the first thing you should have done was to write an equation. Okay, it said write and solve an equation. Well, we got to write it first. And so what we're doing here is we are just writing an equation that'll help us figure out the unknown piece. All right, so you could do a few different things here, okay? You remember that this is the whole board, and this is one of the pieces, and we want the other piece. Well, the other piece is the unknown, so that's my variable. I could make it, the big one minus the small one will equal the other one, or I could do the big one minus the unknown one will equal this one. Or I could add those 2 smaller boards to get the whole length. Okay, there's a few different equations I could have written here. But that is something that you need to do first. You had to write an equation that showed how we can get to our answer. The second thing you had to do, you had to solve your equation. Now, depending upon what you set up over here, this is going to be our answer, okay? The bigger board is 12 3/10 meters in length. All right, so that's the second part. This one looks like a 2-pointer, one for writing a good equation and one for solving it accurately. In the next one, number 7, Catherine studied 1 1/4 hours for her science test. This is a half hour less than she studied for her algebra test. Write and solve another equation to show how long she studied for algebra. Well, we know she studied this long for science. And we know that that was a half hour less than her math test preparation. So a good equation for this one would be how long she studied for algebra. That's what we're trying to figure out. Minus a half, because remember, she studied a half hour less for her science test than she did for her math one. So it'd be math minus a half hour equals 1 1/4. Okay, that would be hours. And if we solve this, we would really want to get the variable by itself. So we add a half hour to both sides. And that leaves us with this right here. X will be a 1 1/4 plus a half. So if I do some converting, 1 1/4 plus 2/4, that's 1 3/4. So the amount of time she studied for her algebra test was 1 3/4 hours. And if we look back at this, that makes sense now, because if this is what she studied for math, and if this is a half hour less than her math test preparation, everything checks out now. All right, so that's a tricky one. Remember, this less than part, that's the part that sometimes messes kids up, because they'll do 1 1/4 minus a half. And that's not really what's going on here. Okay, it's the math test minus a half hour will equal the science test. This next one right here, you had to write inequalities for these scenarios, all right? So you want to remember there's some keywords that kind of let us know what inequality symbol we want to use. So when they say the science test will be no more than 20 problems, no more means that it can be up to or equal to 20, all right? So we would show it like this, okay? The number of problems on the science test, that's your variable, needs to be less than or equal to 20. All right, this one would be correct. If you used a different symbol, if you used a different number, you might want to check with your teacher and see if that's good as well, but this is a very good solution for that scenario. And number 9, the team needs at least 4 more players to enter the tournament. So if they need at least 4 more players, think what that means. That means they can have 4 more people join, or 5, or 6, or 7, or 8. So we would show that one with this. The number of players still needed needs to be greater than or equal to 4. And you could use different variables. You could use P for players. You could have used P for problems in that one. Again, the variable doesn't really matter. What's more important is that you've got the right inequality and the right number. Okay. In numbers 10 and 11, now we are solving and graphing inequalities. Just remember down here, the open dot, closed dot. Okay, that's very important when it comes to graphing them. So if you need to pause and kind of study that before I start talking about these, that might be a good idea. But let's look at number 10. If y is greater than 6, we can graph that on a number line. The first thing we got to do is we got to number the number line. Now, usually we put 6 in the middle. And we can count up by ones, and that would be 7, and this would be 8, and that would be 9, and so on. That would be 5 and 4, and so on. But if y is greater than 6, we want to use an open dot on 6, because y cannot be 6, but it can be more than that. So our arrow goes to the right. We draw an arrow to show that it keeps going all the way past the number line, all the way to infinity, because this just shows the solution set. Okay, this shows all the numbers that will make that true. Y can be 7, 8, 9, and so on. So that's what this one looks like. Open dot on 6 going to the right. Number 11, now we got to solve this first. Okay, we want to get the variable by itself. Like over here, the variable was by itself, so we didn't have to solve that one. We just had to graph it. Well, this one, we got to solve it first. Just like those inequalities on the first 4 problems, we want to get the variable by itself. So we're going to subtract 3 from both sides. That leads us to this right here. And that is really what we want to graph. W is less than or equal to 5. Notice I didn't change my inequality symbol. It's the same as it was in the problem. I've just taken 3 away from both sides to get the variable by itself. So when I graph that, that's going to look like this, a closed dot on 5. Okay, that should be shaded in. And all the numbers that will make this true will be less than 5 as well. Okay, W can have a value of 5. That would make this true. Or it can be anything less than 5, because those would still make this true. Notice 6 would not work, because that would be 9. 7 would not work, because that would make this 10. All right, so we're showing a solution set for the values that solve our inequality. That is how you do 10 and 11. If I look at number 12, you must be over 48 inches tall to ride the roller coaster. We again have to write an inequality, and then we have to graph it. Well, if you've got to be over 48 inches tall, that means your height needs to be needs to be greater than 48. So you have to use that symbol. Your variable is usually listed first, so x is greater than 48. Again, you could have put an h for height or any other number or letter, really. But now we want to graph that. So on our number line, we put 48 typically in the middle. And our heights that would be able to make us ride the roller coaster is everything more than that. So open dot on 48 going to the right. because you can be 49, 50, and so on. In number 13, you want to state three numbers that are solutions to this inequality. That means come up with three numbers that make this true. 5 times a number is less than or equal to 20. Well, if I solve that, if I get the variable by itself, I want to divide both sides by 5. And I end up with this inequality. X needs to be less than or equal to 4. So think about what happens if X is 4. Well, now this is 20, and that is less than or equal to 20. If this is 3, well, that's 15, which is true. If it's 2, that's 10, which is true. So I just listed those numbers, 2, 3, and 4. You could have said X is 1 or X is 0. Okay, there's a bunch of possibilities here, but 2, 3, and 4 would work. If you have anything more than 4, that's not right. All right. All right, this last section here, numbers 14 and 15, you had to graph this. You had to put it on a table, graph it, and come up with the equation. Well, Henry read 6 pages of his book last night. While riding the bus to school this morning, he read an additional 3 pages each minute. Complete the table showing how many total pages he will have read after m minutes of reading on the bus. Then graph the ordered pairs on the coordinate plane. Well, there's a couple ways to respond to this problem. It's a little bit ambiguous, so I'm going to show you both ways to solve it. First thing you could realize is this table right here. If he is reading 3 pages every minute, well, 0 minutes would mean he's read 0 pages. And then every minute would be 3 more pages. So 1 minute, 3, 2 minutes, 6 pages, and so on. This is one way to organize the table. And then if you graph that, well, in 1 minute, he read 3 pages. So over 1 and then up to 3. In 2 minutes, 6 pages. 3 minutes, 9 pages. And 4 minutes, 12 pages. If you approach this problem this way, then you would have an equation that looks like this. 3 times the number of minutes equals how many pages he's read. Again, think about what this means. If he read 1 minute, that's 3 times 1, which is 3 pages. Okay, that's that right there. If he read for 2 minutes, that'd be 3 times 2. He would read 6 pages. If he read for 20 minutes, that'd be 3 times 20. That'd be 60 pages. That would also be in our line here, because this is a linear graph. It's going on in a straight line. Now, that's one way to respond to this problem. The other way is to think of it like this, because sometimes this part right here is kind of important. Henry read 6 pages of his book last night. So if we start the problem there, now things might look slightly different. All right, in number 14, basically you'd be saying he's already read 6 pages. We're going to kind of start all of those with 6, but now we're going to add, 3 more, or 6 more, or 9 more, or 12 more. So this is going to be a little bit different if you start with that number right there, since he's already read 6 the night before. But that would change our graph a little bit. Okay, now in 1 minute, he's read 6 pages right there. Sorry, in 0 minutes, he's read 6 pages. Oh, my graph is wrong. Mr. Herndon made a mistake here. In 0 minutes, he's read 6 pages. So there should be a dot right here. In 1 minute, he should have read 9 pages. So all of these dots should be slid over a little to their left. I am catching a mistake during the video. You can probably blame Miss Rankin for that one. It's her fault. All right, so this is another way to think about this problem. To be honest, I don't think the problem really tells you if you should think about the 6 or not think about the 6. So, if I was grading this, I might accept both answers. But this does change our equation as well. Now it would be 6 plus 3 times the number of minutes equals how many pages read. You can see here I've labeled my variables with what's what. So this would be like 6 minutes, 6 pages plus, however many minutes he's read on the bus times 3 will equal our pages. That's what kind of summarizes this right here. All right. Okay, that brings this to a close. Possible next steps. I mean, we just went over a study guide. So let's talk about what next steps could look like. You could definitely learn from the ones you missed. It's a good idea to correct them, look for your mistakes, understand your mistakes, because you know that very often your test is coming back at you just like your study guide was. You could also think about the test problems and how they could be different, okay? Because, the test is different from your study guide. There's usually some small changes here and there, some new problems, some different problems. So brainstorm, how could this one look? How could that one look if they wanted to change it on me? You could look back over the skills you want to strengthen for the test. You probably know now which ones were good and which ones were tough. Okay, so you might want to look back over those and learn from some of the things you felt like you were missing. Okay, you could practice some more and review some more, right? These are all good steps, okay, and we will provide you with some resources to make that happen. But this brings this particular video to a close. Thanks for watching. You've been a great audience.